Hello and welcome. In this video I'm gonna show you how we can use the chain rule to find the nth derivative of some functions. Find the 100th derivative of the function y equals e to the negative 2x. Maybe you think that for answering this question we have to find the derivative of this function 100 times. Not really. We are not going to find the derivative 100 times. We are going to find the first, second, third, or maybe fourth derivative. Then we try to find a pattern in the derivatives, and then from the pattern we try to guess the desired derivative, which in this case is the 100th derivative. So let's start by finding y prime. For finding the derivative of e to the negative 2x, we remember that the derivative of exponential function is itself. Remember, the derivative of e to the x is e to the x. E to the x is the only function that its derivative is itself. But here we don't have e to the x, we have e to the negative 2x. So we have to use the chain rule. The derivative of e to the negative 2x is itself times by derivative of the inside. The inside is negative 2x and the derivative of negative 2x is negative 2. So y prime is negative 2 e to the negative 2x. We can put this coefficient in front. This is the first derivative. Now let's find the second derivative. We want to find the derivative of this function again. The negative 2 is a constant. And when you want to find the derivative of a function, just copy the constant, copy the coefficient, and take the derivative of the variable part of the function, the part that is with variable. Copy the constant. Use the constant rule. You don't need to use the product rule here. So we write the negative 2. So we have negative 2. Now we have to take the derivative of e to the negative 2x again. But we know that the derivative of e to the negative 2x is e to the negative 2x times negative 2. If we simplify this, negative 2 times negative 2 is 4. I know this, but it's better to write it in this form. And in a moment you will understand why I am not going to write it as 4 and I am writing it this form. Negative 2 to the 2. Now let's find the third derivative. Again, we write the coefficient, we write the constant first. And we take derivative of e to the negative 2x. Derivative of that is e to the negative 2x times negative 2. Again, if we multiply this by this, negative 2 times negative 2 to the 2 is negative 2 to the power of 3. Negative 2 to the 3 times e to the negative 2x. If we continue this procedure, can you guess that what would be the 100th derivative? Attention! The first derivative is negative 2 to the 1. The second derivative is negative 2 to the 2. The third derivative is negative 2 to the 3. What is the 100th derivative? If we continue this, the 100th derivative which we want to find would be negative 2 to the 100, and always the original function is here. So times e to the negative 2x. So this is the 100th derivative of that function. If you want, instead of negative 2 to the 100, because the power is even, we can simply write 2 to the 100, because when negative raises to the power even, negative cancels. But you can leave your answer in this form. So if you want, you can rewrite your answer in the form of 2 to the 100 times e to the negative 2x. Now look at this question. If y is sine of 3x, find y prime. y double prime, y triple prime, the fourth derivative, and finally we want to find what is the 99th derivative. So let us start with y prime. Derivative of sine is cosine. Derivative of sine of 3x is cosine 3x. But don't forget to multiply by the derivative of the inside, and the derivative of 3x is 3. You can write the 3 here, but it's always better to write the coefficient in front like this. So y prime is 3 cosine 3x. Now let's see what is y double prime. We keep the 3. Derivative of cosine is negative sine multiplied by derivative of the inside, which is 3. 3 times 3 is 9, and we have a negative. But similar to the previous question, instead of writing 9, it's better to write it as 3 to the 2. So what is the second derivative? The second derivative is negative 3 to the 2 sine of 3x. Now let's see what is the third derivative. We keep negative 3 to the 2. Derivative of sine is cosine, and derivative of the inside is 3. 3 times 3 to the 2 is 3 to the 3. So the third derivative is negative 3 to the power of 3 cosine 3x. What is the fourth derivative? It's not a bad idea to pause the video right now and try to find the fourth derivative by yourself, and then continue watching the video. We keep the coefficient. Derivative of cosine 3x is negative sine 3x times by derivative of inside 3. 3 times this is 3 to the 4. So the fourth derivative is 3 to the 4 sine 3x. Attention, derivative of cosine has a negative, and that negative cancels with this negative here. If you pay attention, we started with sine of 3x. After taking the derivative of sine 4 times, we got to the original function, but we got a 3 to the 4 here. So this shows that every 4 times that we take the derivative of sine or cosine, you can check it later by yourself, that for sine and cosine we have this rule. Every 4 times that we take the derivative of sine or derivative of cosine, we back to the original function. Look at here, derivative of sine is sine again after taking derivative 4 times. Of course, we have this extra coefficient here, and that's because of the inside. Every time we take derivative of inside, we get a 3, 3, 3, and 3. So after 4 times, we have 3 to the 4. So far, we know that if we take derivative of sine or cosine 4 times, we back to the original function. So derivative of sine every 4 times is itself. So if we take derivative of sine 4 times, 8 times, 12 times, 16 times, every multiple of 4, its derivative is itself. But the 99 is not a factor of 4, so we cannot conclude that derivative of sine after 99 times is itself. But if you pay attention, a number that is close to 99 and is a multiple of 4 is 100. So if we take derivative of this function 100 times, its derivative is itself, and what we have to put here? 3 to the power of 100. Why? Attention, for the first derivative we have 3 to the 1, for second derivative 3 to the 2, third derivative 3 to the 3, and fourth derivative 3 to the 4. But we want to find the 99th derivative. One derivative before this. First of all, we don't have 3 to the 100 for the 99th derivative, we have 3 to the 99. But look at here, In the fourth derivative, we have sine. One step before, we have cosine. But not only cosine, we have a negative also. So put the negative here. Now we know what is the 99th derivative of that function. And you can continue backward for finding the previous derivative. So for example, what is the 98th derivative? If you want to find, for example, 98th derivative, it is negative 3 to the 98 sine of 3x. So it is like a cycle. You can go forward and backward. Now look at this question. If y equals 2 to the x, find the 10th derivative of that function. First we have to find y prime. Derivative of 2 to the x is 2 to the x ln of 2. Let me remind you, in general, when we have b to the x, which b is a number, derivative of b to the x is b to the x ln of b. So derivative of 2 to the x is 2 to the x ln of 2. What is the second derivative? This is a constant, this is a coefficient. Keep it here. Take derivative of the function. You don't need to use any product rule. Derivative of 2 to the x is again 2 to the x times ln of 2. But we have this ln of 2 already here, so times ln of 2. Which you can write this in the form of 2 to the x times ln of 2 to the 2. Can you guess what it would be the third derivative? 2 to the x times ln of 2 to the 3. So the first derivative is 2 to the x ln of 2 to the 1. The second derivative to the 2 and third derivative to the 3. So probably you can guess that what would be the 10th derivative. 2 to the x times ln of 2 to the 10. Now look at this question. Find the 100th derivative of the following functions. The first function is y equals x times e to the negative x, and the second function is sine to the 2x. This one is a bit tricky. Let us start with the first function, x times e to the negative x. For finding the first derivative of this function, we use the product rule because we have to. It's x times e to the negative x. Derivative of x is 1 times e to the negative x, plus we keep x and we take derivative of e to the negative x. What is derivative of e to the negative x? Is itself times derivative of the exponent, which is negative 1. If we simplify our answer, derivative of x e to the negative x is e to the negative x. Let me simplify it and rewrite it here. E to the negative x. What is this? This is negative x e to the negative x. So we can write it in the form of negative x e to the negative x. Now let's find the second derivative, y double prime. If we take derivative of e to the negative x, it is negative e to the negative x. Why? Because derivative of e to the negative x is e to the negative x times derivative of exponent, which is negative 1. It's better to put the negative in front, so it is negative e to the negative x. Now we want to find derivative of this. Again, we use the product rule. Derivative of negative x is negative 1 times e to the negative x, plus write the first function multiplied by derivative of this, which is again e to the negative x times negative 1. This negative times this negative is positive, and if you add these two together, negative e to the negative x minus e to the negative x is minus 2e to the negative x. So let me erase it and rewrite it as negative 2e to the negative x. And here we got positive x e to the negative x. So basically we have plus x e to the negative x. Maybe you can find the third derivative without taking any derivative. Look at the pattern. In the first derivative we got e to the negative x. In the second one we got negative 2e to the negative x. And in the first derivative we had negative x e to the negative x, and in the second one we have positive x e to the negative x. Can you guess what would be the third derivative without taking derivative? It would be positive 3e to the negative x minus x e to the negative x. If you pay attention, alternatively the sign changes: positive, negative, positive. Here we had 1, then 2, then 3. And if you pay attention, the sign of x e to the negative x also alternatively changes: negative, positive, then negative. If you want to make sure this is right, you can take the derivative of this and you will see that it would be this. Now that we have found the pattern, we can guess that the 100th derivative is 100 e to the negative x, but not 100. Why? If you pay attention, in the first derivative the coefficient is positive, second derivative is negative. So for even derivatives, when we take derivative twice, 4 times, 6 times, the coefficient of e to the negative x is negative. So in the 100th derivative also we have a negative. So we have negative 100 e to the negative x. Try to find the sign of x e to the negative x. Attention, here is negative in the first derivative. In second derivative it is positive. Third derivative negative. So in the 100th derivative, the coefficient of x e to the negative x is positive. So we have plus x e to the negative x. Now let's see how we can find the 100th derivative for the sine to the 2x. Y prime, derivative of this function, is bring the power 2 to the front. Attention, sine to the 2 is basically sine of x to the 2. So now take derivative with the power rule, bring the power 2 to the front, subtract the power by 1, so 2 times sine x to the 1. But don't forget to multiply by derivative of inside, and derivative of inside is cosine x. So the first derivative is 2 sine x cosine x. But if you want to find the second derivative from this, maybe you can find the answer, but it would be a bit harder. If you have a good knowledge of trigonometry, probably you remember from double angle identities in trigonometry that 2 sine x times cosine x can be written as sine of 2x. If you remember, we had this rule in trigonometry that the sine of 2 theta is 2 sine theta cosine theta. So instead of this, instead of 2 sine x cosine x, we can write sine of 2 theta. This was one of the most important double angle identities. If we use this identity, so instead of this 2 sine x cosine x, we can write y prime as sine of 2x, which is simpler. Why we prefer not to continue from this, and we prefer to write this instead of that? Because if you want to find the derivative of this in this form, you have to use the product rule, because you have 2 sine x times cosine x. That's the reason we prefer to use this identity. Now we have just one term, sine of 2x, one function. We don't need to use any product rule. Now we want to find derivative of this. If you remember from this question that I showed you here, every 4 times that we take derivative of sine or cosine, their derivative is itself. Now back to this question. Sine to the 2x. We took derivative once. How many more times we have to take derivative? 99 times. Because already we have taken derivative once. And we have to take derivative 99 times. So, the question is this. What would be derivative of sine of 2x if we take derivative of this 99 times? Every 4 times its derivative is itself. But 99 is not a multiple of 4. So again we say if we take derivative of this 100 times, again 100 times, its derivative is sine of 2x times by 2 to the 100. Because 100 is a multiple of 4, so derivative of sine is itself, but because of the inside, derivative of 2x every time is 2, so we have this 2 to the 100. But we want to find derivative of this 99 times, not 100. So if you remember from the question I showed you here, after 4 times, we got the original function. So after 99 times, we have to move one step back. The derivative is cosine with a negative. So similar to that, if we take derivative of this 99 times, the 100th derivative would be negative 2 to the 99 cosine 2x. You should not be confused why I wrote 100 here, because already we have a prime here. If we take derivative 99 more times, it would be the 100th derivative. And so the 100th derivative of this given function here is this. So we took derivative once, we got this. We use one of the trig identities and we rewrote this in this form. Now we have to find the 99th derivative of this. The 100th derivative of this is itself. So 99 is one step before the 100th, so its derivative is this. The reason that we have to put these 2 to the 99 is because of the inside derivative of 2x is every time 2. It generates a 2 for you at every step. I hope you liked this video and see you in the next videos.